And we're live. Let's see. I wonder if my live coding overlay still works. Looks like it doesn't. So let's go ahead and turn that off for now. Hope everyone's doing well this evening. I'm going to turn my audio down just a bit. There we go. Well, we just deployed our Kubernetes cluster. And now I need to go ahead and take a look and see. Let's see, I've got my performance testing notes here. I need to go ahead and actually get access to this Kubernetes cluster on my local machine. So let me go ahead and grab my Kubernetes cluster here. So we're deploying, or rather we have deployed. Another thing I can do is turn down the music here. Maybe I'll pump up the audio level a bit in Twitch, but on my Bluetooth headset here, it's pretty quiet. And I apologize a bit for the audio quality on my microphone. I'm using my Bluetooth headset tonight because my studio microphone is back at the office. We're shooting a bunch of YouTube videos this week, and I no longer have access to it. Well, let me rephrase that. I just left it at the office. I didn't want to bring it home with me. Okay, merge, stress, blah, 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 as current context in the kube config. All right, that's great. Go ahead and see what I've got in my monitoring namespace. All right, looks like I've got Grafana up and running. Go ahead and grab that. Let's go to import 3000. Go ahead and log in here. Nope, that's all right. I need to go ahead and import a couple of dashboards. So first, I'm going to go ahead and grab some of the Phobos dashboards we're going to be using. We are using Prometheus on the back end here to go ahead and power all of our metrics. And even though I haven't deployed my app yet, I still want access to my Phobos dashboard for being able to monitor the status of the cluster. That's going to basically tell me if we've reached our full complement. That is here. Here we go. And let me go ahead and grab. Yep, here we go. That's the dashboard number. Great. Go ahead and load that in here. Set the Prometheus data source. That was good. No data yet. That makes sense. We haven't deployed anything. I'm blanking on the name of this Kubernetes Grafana dashboard that I used a bunch of times. Here it is. I remember the number now. 315. Go ahead and load that. All right. So cluster member usage is pretty low. File system usage is pretty low. And we're not using any CPU yet. So we are running on a total of 48 cores. That makes sense. I don't remember the exact spec of the VM that we're running on, but it's 16 cores. I think it's a relatively older generation Intel machine. So not the best in class, but still bigger than a production Kubernetes cluster that I run. And we have, yeah, close to 165 gigs of RAM to work with here. And right now, all that's running inside the cluster, let me take a look at one more thing. Let me pull up Azure Monitor real quick. Let's grab the metrics. Now, how's everyone doing tonight while I'm getting everything set up here? Number of pods in ready state. So we're running a total workload of 29 pods. All right, that's good. Save that. I need to go ahead and add, let's add CPU. And I personally don't like using millicores. I prefer percentage. And then let's go ahead and add some, I guess we're not really messing with bandwidth much tonight, so I guess that probably doesn't matter much. So we're running with about 29 pods so far inside the system. I'm going to shrink my time frame down just a bit. Oh, Malcolm, good to see you, man. So we're running about 29 pods. Some of these are built-in Kubernetes service pods for doing various things, but most of this is going to be our application performance monitoring namespace that I deployed via Pulumi just a second ago. So by the way, this code sample I'm working with tonight, I'll drop a link to it in chat. I just open sourced this yesterday. This is basically what I've been using to stress test our network. So it does depend on Phobos. However, it's pretty easy to go and disable that if you want to try it without buying a license to Phobos. But I've been using this to go ahead and test various configurations of Akka.net for one of our customers who runs a 200 node cluster in production all the time. And they run on much nicer hardware than we have. They run on big on-premise machines that aren't virtualized or anything else. But I'm sticking with what I've got access to, which is commodity hardware courtesy of Windows Azure. So I've been taking pretty extensive notes on some of our performance tests so far. I've got some, this is Notion, which is like, I would call it Confluence for millennials, is basically what it is. And I'm keeping track of a number of different metrics here. I've got one more dashboard I need to import. I'm planning on open sourcing this as well, but let's see, latency.json. Nope, here it is. I'm planning on open sourcing this as well, but basically I went ahead and I made a dashboard that can consume the metrics exposed by .NET Monitor, which is a CLI tool built by the Microsoft team. I am exposing those metrics in Prometheus format and importing them. I don't know what my changes are, but I'll save them. Oh, whoops. Just accidentally created a new dashboard. That's not what I meant to do. Go ahead and import your JSON. Prometheus default. Process threads, total alive members. Do I have one more? Do I have one more .NET? Yeah, here we go. I've got one more, as it so happens. All right, let me grab this. Import this dashboard as well. We have some panel JSON here. Oh, looks like I already added three. Okay. You go to browse. There we go. This is another dashboard I built for .NET Monitor, which I will open source. Not to distant future here. Okay, things are looking pretty good. I should be authenticated against my cluster now. Let me go to this folder. This is the Kubernetes/prod folder. And we're going to go ahead and run the deploy all script. And this should work no problem. And I'll go ahead and run a little command here. I think Akka stress is my namespace. So basically, the number one thing I need to look out for right after we go and deploy our Kubernetes cluster the first time is I need to make sure that my configuration for pulling my custom images out of Azure Container Registry still works. So it looks like it does. We got one front-end pod running. Our first back-end pod is now running, so that's looking pretty good. Let me take a look on Azure Monitor. This can give me kind of my raw pod count here. This is Azure Monitor is pretty slow to update, so it looks like I don't see anything in there just yet. If I go and flip over to my Kubernetes pod resources, this is the older dashboard. Yeah, let me discard that. So we can definitely see right here, looks like this is some images being pulled as part of our initial deployment here, so something's definitely happening. And okay, here we go. State of my cluster. I have 4 up members so far, and I believe if I take a look at, let me go ahead and pull up. Close that. Let's see. Here we go. If I take a look here, get rid of some of this crap. Yeah, don't need any of that. Don't need any of that. Nope. Don't need that either. Okay. If I take a look at my services.yaml here, we're going to deploy 3 front-end nodes, I believe. Yes, 3 front-end nodes and 197 back-end nodes. The image we're deploying is 0.5.12, which is what we have as the sort of current, most recent commit here. So this is running .NET 6, I believe. we are using, if I take a look at my configurations here. So one of the things I've done with this sample, by the way, is I've made it highly configurable, so I don't have to change code around in order to test different conditions. So we are using Akka management to go ahead and form this cluster. So that means we're doing service discovery, and we're doing that using this pod label selector here. So we're looking inside this namespace, looking for pods of this label. That's what Akka.cluster is going to use to form itself, and we can tell that's working because we can see our clusters growing pretty quickly right here. We're up to 12 pods so far. So rolling out 200 total pods with a stateful set will take a little bit of time due to some of the readiness checks involved and so forth, but we're going to let that run in the background. We're using the channel executor in Akka.NET, which is all built on top of the .NET thread pool. Rather than trying to use multiple different thread pools to separate high and low priority workloads from each other, we basically use these virtual task queues that are built around system.threading.channels. And this has resulted in a significantly lower CPU consumption inside Akka.cluster, about 1/5 of the CPU consumption that using the normal Akka.NET defaults does. We're going to make this default on Akka.NET 1.5. We have Akka.persistence enabled. We have a secret that we actually emit into our Kubernetes cluster via Pulumi that basically passes in an Azure storage connection string in there. In fact, that reminds me, I should check to see what our error rate is. Looks like we haven't logged any errors, so we probably aren't having any issues with Akka.cluster sharding just yet. One thing I can also do, let me put out of this, is I do have petabridge.command installed inside this cluster. So we go ahead and do kube control exec. We'll do pbm, cluster sharding, region stats, items. This is going to query the total number of shards and entities that are spread out throughout my cluster right now. I actually am thinking I want to expose this via Phobos too at some point so people can make dashboards around it. But basically I can see that it looks like the sharding system is running just fine. And this configuration, if I'm not mistaken, is using Akka.persistence for sharding behind the scenes. Let me just double check all of that. Config prod, Kubernetes discovery. Use DData is disabled. Okay, so this should keep bandwidth consumption down quite a bit inside the cluster. DData is the other way of being able to store sharding data inside Akka.cluster. It uses conflict-free replicated data types, which are these sort of eventually consistent, mutable data structures that get merged together. Well, immutable data structures that get merged back together again. But it uses quite a bit more bandwidth than Akka.persistence does. So that's what we're using. Okay, so everything looks pretty good so far here. So I'm going to go ahead and let my sample keep running. It's going to take a little while for all my .NET 6 nodes to be deployed. While that's happening, I need to create a new branch and begin migrating my code to .NET Core 3.1. So we'll create a new branch here. And if I go to my directory.build.props, I have the ability to go and change the framework version for all of my apps in one spot here. So we'll change this to .NET Core App 3.1. And then this should probably cause Rider to freak out because it's going to invalidate all my symbol caches. Yep, there we go. And basically, all this sort of minimal API applied namespace stuff is supported on .NET Core 3.1, so I'm going to have to refactor all my files probably. Not the end of the world. I think it's probably going to be search and replace-ish, but it is going to be a little bit of a nuisance. So let's go ahead and give this a try. Do that. Let's see, pinger actor. Yeah, I'm probably just gonna have to do this for all these files here. It is a nuisance, but it's not the end of the world. Okay, that looks good. I probably need to go and update my message classes. Yeah, it's all these shared infrastructure components are gonna be what I need to fix, because without that, nothing else will be fine. So let me do that first. Normally people do this the other way around, but because I started this off with .NET 6, I have to do it backwards. So that's okay. Go ahead and do this here. See how quickly I can get through this. Yep. There's some extra white space there. We're using Akka hosting, by the way, to go ahead and run everything in the sample. That's one of the reasons why I can go ahead and I'm actually using Microsoft.extensions.configuration to configure everything inside my app. All of the Hocon stuff like this is basically being injected behind the scenes. We're going to build some Akka hosting, let's say first class sort of citizens for libraries such as, I'm using Akka.persistence.azure in here. We will have Akka hosting methods for that as well at some point in the not too distant future. For right now, we only support, I think it's Akka.persistence.SQL server and Postgres too. I'm getting a red anger squiggle here, which tells me that I am missing a curly bracket. All right, good to go there. Let's go ahead and fix that. Yeah, this should only take a couple of minutes. Feeling pretty good about it. All right, that's good. I can test this locally before I try deploying to, which I might do. I just gotta make sure I remember to change my kube config to go ahead and deploy it locally. So these are some of my different dispatcher options that I can test. I've actually never bothered testing this one. It's only these two that I've really worked against. And the results were so drastic from the defaults, the channel executor, that I've decided that I probably don't want to go back to using the defaults again. I think that the channel executor should be the new default. Okay, that looks pretty good. These are some of my dispatcher Hocon configuration options that I can toggle between. In fact, yeah, this is some of my application-specific extension methods I built for Akka hosting. This is the way Akka hosting is kind of meant to be extended by users, is you add your own extension methods that piggyback on top of the Akka configuration build that have application-specific code for use. In this case, we've got some actors that create message traffic for our sharding system. We've got some actors that perform readiness checks. We've got a little method here for adding petabridge.command. I will also build in a petabridge.command Akka hosting method as well at some point in the not too distant future. Up until today, I have been very focused on getting Phobos 2 shipped. And Akka hosting, while it's very exciting, has taken a bit of a back seat to getting that done. Looks like I already updated this. What am I missing? I'm missing my commands. Okay, we'll get to that next. Okay. All right, that's all done. All right, so of all of you who are attending this evening, who of you has had experience running an Akka.NET cluster before? I'm pretty sure Malcolm has, who I saw earlier. Oh no, I can't do records? Oh, jeez. What a pisser. Okay. Well, that's going to make this a little bit more interesting. Uh-huh. Let's see, introduce read-only field. Yeah, okay. Yeah. Go ahead and do that. And then I can go ahead and do add item. the old way of doing it. All the F# users are going to be laughing at us. Okay, we'll do that. I guess I gotta do that for this class too. What a bummer. Jeez. Well, thankfully I don't have too many of these. It's not the end of the world, but still. I like using record types when I get the chance. So yeah, I'm going backwards here. Public remove item. And let's go ahead. Get auto property. Counts. This should make me roughly back into battle. Architecture has a nice value object-based class for the same purpose. Well, you know, I slapped this application together on pretty short notice and wasn't planning on doing CQRS stuff with that. I wasn't even planning on using cluster sharding at first, but then I kept needing to oh, dude, no. Okay. I gotta do this again. This is what I get for separating commands and events. Whatever. Gotta do it. Do that. Architecture is a great library, though. Hope you don't need to override the equals method. Dude, you people are mean. I hope not either. Don't think I will. These world is meant to be immutable commands and events. Looks like I'm logged into Steam. Probably because I restarted my computer. Right. That. You know, every now and then, I like to go ahead and get a little bit of Dark Souls in. I've been playing that recently. I know all the cool kids are doing Elden Ring, but I wanted to start with one of the classics. I've also been playing a little bit of Civilization 3. Not Civilization 3, Civilization 6, anytime I get the chance. It's been tough, though. We've had a lot going on at work. I had a lot going on outside of work. It is what it is. I haven't actually gotten to do much work on Akka.net itself, other than reviewing pull requests lately. I was just talking to Gregorius on the Petabridge team about that. I feel like I have a bunch of creative energy around the Akka.net 1.5 roadmap that I would like to act upon, but I've just had too many other little things I've had to do recently. But with Phobos 2 out the door, that's one of my biggest commitments for the year. I should be in a lot better shape. Able to go ahead and get back to doing some of my individual contributions to Akka.net, which I always really enjoy doing. I've also been working on quite a few new code samples. It's one of the other things I've done. This is one of them, but I did a total of 3, I think, did a total of 3 over the past month or so. Let's see. Gotta go back to here. Pull this file back up again. Okay. Stick all that together. That looks good. Okay, why I don't even need records for this type. Records sure are convenient. Wish I had them in .NET Core 3, but I do not. So let me go ahead and convert this back. Okay. Am I missing something there? Let's see. Probably the property that interface expects. Got it. All right. Got that done. Oops, nope. Wrong order of operations. I don't think I actually need to increment anything on this particular record. So I'm not going to bother with adding a with count method or whatever. That was good. Boy, this is killing me. All right. I'm still going to have to fix some of my actor code too, unfortunately. I know that's one of the next things I'm going to have to deal with in just a moment, but it is what it is. Yeah. Guess I got to rename these. Well, I'll worry about renaming that once the underlying type is working. So I think I've got a bit of a problem here. Yes, I think that's probably it. Oh, never mind. That's gonna go. Now I can rename these. Let's see how our cluster's doing. Let me get GitHub up and running again here. All right. Yep, looks good so far. Converting classes to .4, to .1. Good, with that. So I'm downgrading the .NET version because, you know what, this is going to fail because I need to start the GPG agent. Oh, never mind. Looks like it worked without me. Great. My GPG signing was not running. Okay, great. We're downgrading the .NET version in order to compare the performance of .NET 6 to .NET Core 3.1. I built this application originally using .NET 6. So if we go to here, I can see that my cluster has, we're just a little bit over halfway there. I have 113 nodes that are up, one unreachable node. Error rate looks pretty low. Let's take a look at, if I go and reload this. There we go. This is now factoring in all of the actual nodes in my cluster here. So I'm doing processing on the backend service about 2.7 thousand messages per second. This is distributed across all those nodes. And then on the front end, we're doing like 1 request per second, which makes sense. I wonder if this has distributed pub sub enabled, this particular application. Let me double check that. I disabled distributed pub sub. Okay, got it. So no, we don't have it enabled on this one. So that's why we're downgrading the .NET version. If I go and take a look at my graph here, so for some reason it's not getting me a CPU utilization value. Yeah, not seeing it. Weird. I had this issue recently as well. I wonder if they want me to go and pay for something extra to get that data now. That would not surprise me. Let me go ahead and open up Grafana and let's take a look at our what this has to say. So it looks like we're operating at 7.2% of the cluster's CPU being utilized and just under half its memory. Memory is what we're going to peak out on first inside the system. It's actually probably the limiting factor in being able to control our growth is the amount of memory we have. Part of that is due to the sheer number of connections. Every single node in the cluster needs to be connected to every other node in the cluster. So it's 199 connections per pod. And each one of those pods is going to allocate, I believe it is 4 megabytes per socket. So you go ahead and you add that up and you end up getting, you're basically going to end up consuming quite a bit of basically about 800 megs per pod is going to be used on just buffers for sockets. So I can actually scale that value down if I want. I didn't because distributed data would vomit. Trying to go ahead and distribute its replication messages for cluster sharding once we got above, I think, about 150 nodes to the cluster. Why did I pick .NET Core 3.1 versus .NET 5? Because I originally built the sample app for a customer, and .NET Core 3.1 is what they're running. So I decided to go ahead and work across purposes here and essentially reproduce an issue for a customer and turn it into a Twitch stream. Since this is a code sample that is open source and basically is pretty safe to go ahead and put public. So that's why I decided to do that. And the reason why they're using .NET Core 3.1 is because of the long-term support. They haven't literally told me that, but that's my assumption. I think they want to upgrade to .NET 6, but I think maybe they've been holding off on doing that. All right, so what else do I need to upgrade in this sample here? My item messaging actor is probably in bad shape. Let's take a look. What else is going to fail compilation? Allocations.net messages that will be using this is not good. Okay. Go ahead and build that. Is there a way for me to even get access to that? Okay, cool. Looks like that's what fixed it. All right. Good deal. Go in here, get rid of that. Let's see if there's anything else in my infrastructure. I got to import a system namespace for that to work. Let's take a look at this. I'm missing link. Actually, I think I'm missing systems.collection stuff. Oh, let's take a look at our namespaces using. Where's my select statement down here? Seed nodes is. Aha, that's why that's not working. Oops, get rid of that. Okay. Get rid of that. Item messaging after. Oh gosh, we're missing this stuff too. A lot of useful syntax that was added between .NET Core 3.1 and .NET 6. All right. Yeah, I got you. So I'm going to need to update my actual deployed projects here. Listen usings, we'll get rid of that. Backends. All right, go ahead and recompile everything. Let's see, namespace. This is backend, right? Nope, this is the front end. Okay, that explains why that didn't work. Okay. Let's go ahead and move all that into here. Program public static main string args. Is that how you define a main method? Yeah, I know. .NET Core 3.1 definitely is. Let's see. I think I need to go ahead and do, is it params? I think this should do it. Okay. Yes, and not having the minimal APIs would suck. We import that. Oh, God. What a pain. Okay, so I gotta go and convert the ASP.NET stuff to .NET Core 3.1. That's not something I was prepared to do. Let me see if I can pull up. This is a .NET Core 3.1 sample. I'm gonna have to go ahead and steal some configuration code here. Yeah, why don't we go ahead and do this? Alright, so we'll go ahead and do We'll go ahead and do configure logging. And we'll go ahead and do that. That looks right to me. Good news is that once I do this once, doing it for the other samples should be pretty easy. Do that. Web builder. Well, I don't need to use. Huh. No, I don't necessarily need to go ahead and use the web builder to configure services, I guess. I guess I can just do that here. And I'll go ahead and tack this on. Let's see. Actually, one thing I'm going to need is I do need to enable, let's see, configure web host. I do need to add environment variable support. Let's see, I don't remember how I do that. Yeah, tell you what, let me go ahead and leave that for now. Let's see. Blob service client, nice try. Builder.configuration. Don't need that, no. Configure app configuration. I think that'll do it. Perfect. That's good. Need to add environment variable supports. Then for configuring services, I can just copy and paste this into there. Provided that I can get access to context. Let me try this one time. Configure services. That's what I wanted. Good. Needed that overload with the context. And so I can go ahead and grab. And we'll go ahead and do context. Perfect. That looks good. So get rid of that. Get rid of that. Get rid of that. Then the rest of this, I can go ahead and tack on here. I'll go ahead and rename that. Alright, that should configure Akka.net. Any of the default builder adds environment variables as a config provider. I thought I had to do this in order to register the Microsoft.extensions.environment variables. That was what I recall, but I'm not 100%. One thing I need to do is add OpenTelemetry support. Alright, that looks good. And then finally, I've got to go ahead and actually do my app. Let's see, where do I get the web host builder to go ahead and do the app config here? There we go. Perfect. That's what I was looking for. Now, I know some of this isn't going to work. Yeah, this was a nice try, but this is something brand new they added to .NET 6. That's not going to really fly here. So what I can do instead is do rec. Let's see, services. Get the active registry that way. And then I'll make that async. I think that should work. And then what do I need to return? All right, and then we'll go ahead and just return. I don't know what I just did there. I think I accidentally copied my lines. Let's go ahead and return the string.empty. All right, that should do it. And then, no, what is it want as a return value? Return type is void. All right. You're the boss. Okay, great. So I'll go ahead and do call build, run async. All right. That looks good to me. Now I'm going to go ahead and make sure if I go to properties, debug, just to make sure I've got an entry point. Let me go ahead and try running the Akka.net front end. See if that will go. Apparently missing a hash step. And what else am I missing? All right, let's go check on our cluster. Up to 77% memory usage. And here we are at a full complement of 200 nodes now. Let me go ahead and reload. Okay, so this took about half an hour for me to get there. Total errors log 0. Our spread of actors, so the newer nodes simply don't have as many because the shards take a little while to get rebalanced. So there should be some message traffic from that. So we've got some persistence recovery timeouts. Looks like most of the message traffic so far comes from actors receiving new messages to add via cluster sharding, replaying existing messages. These are all lock-it-up persistence recovery down here. These are some of the timed messages that we have going on behind the scenes. Some write lock-it-up persistence. So overwhelmingly, it looks like lock-it-up persistence to me. Looks like inside the cluster, we have 232,000 actors have been created, 209,000 killed, another 234,000 actors. These are responsible for running lock-it-up persistence recovery that have been created, and a bunch of them have been killed. 2,000 actors, 2,100 actors for posting shards, and 72 of them have been killed off. Okay. Looking pretty good so far. Front end does not have a huge amount of traffic on it. That's to be expected. Looks like we have some nodes that are being kicked out of the cluster, so there might be a little bit of an issue with the cluster reaching consensus in some areas here. That's kind of what that looks like. Some of that could be because we're starting to run out of memory and pods might be getting affected. Let's go ahead and take a look at all. Let's take a look. Anybody been evicted? Doesn't look like it so far. That's good. We do have all 200 pods there. So in terms of our CPU utilization, I'm going to need to wait for this graph to repopulate. I don't know why it's missing data right now, but I think we're sitting at about, let's see, past 5 minutes. Network pressure here. Looks like we're doing about, 50 megs a second worth of I/O inside our system. Nearly 80% memory utilization. That's really going to be where this system peters out. The CPU will probably be, I'd be surprised if it was 20%. It's probably going to be a little bit lower than that. Let's see if Application Insights can give us any numbers. We're at 230 pods. It's not going to show me memory for some reason. Let's go ahead and add a couple other metrics. Total amount of cores requested. What's the amount of available CPU cores? That's stupid. Who cares about that? Looks like I'm not getting any like basic memory or CPU metrics out of Application Insights right now. That's really kind of annoying, actually. Let's see. I don't want to turn on a log analytic space. I just want to see the amount of CPU. Let's see the last 30 minutes. Nothing. That makes it a little harder for me to go ahead and measure what's going on. Let's take a look. Let's go ahead and take a look at, get rid of that. Let's take a look at what .NET Monitor has to show us. So this is keeping track of 200 different pods. So completed items in the work queue. Looks like we've got some older pods here. I wish I could have the pod DNS show up and make it a lot easier to tell what's going on. But looks like this is probably our first node of the cluster, first backend node, has completed 2,700 items. And by the way, this is probably also the focus of the shard coordinators. It's going to be a little busier than everybody else. Thread pool, thread count. Looks like the total number of threads reported by .NET Monitor is around 15, 16, with some nodes getting as high as 36. That's on 1035. Totally different node than the one with the high number of completed items. Queue lengths are staying between 1 and 0, so there's not a huge backlog. The .NET thread pool is looking pretty good. CPU utilization is all over the place. I don't really even consider that data to be all that useful, frankly, just because it's a like binary distribution. It might even be a problem with the way it's getting reported to Prometheus, will be part of it. Okay, now in terms of our memory utilization allocations, though, this data coming out of .NET Monitor is very good. Not a huge amount of time being spent in garbage collection by this app. That's about what I expect to see here. Large object heap, 37 megs. Gen 2 size, 43. And it varies by node. But these are not huge sizes. There's some fragmentation across the board here, but it's generally staying at about 30% or below. And then total memory sizes at the very bottom. We have some that are like 80 megs. At the very top, we have 800, which is 800 is about right. It's sort of the right ballpark for this stuff here. We're not allocating a huge amount. So one thing you'll notice is the allocation size here and the managed heap, like the working set, are very disparate. They're off by a factor of 20 from each other. The reason why that is we're actually not creating a huge number of managed objects, even in a busy cluster like this. Most of the memory that's being used comes from buffer space, which is managed by the operating system, not by the .NET runtime. So it's because these are system level memory buffers that are being allocated. They count towards the working set of the process, but they're not managed by the garbage collector. So that's one of the reasons why these are a little bit different. So these working set values are high, these GC heap sizes are a bit lower. So that's what's going on with that. And I have one more dashboard to look at, which is, where's my Akka stress dashboard? Folder current, I don't want to look at this folder, I want to look at all of them. Akka stress metrics, here we go. Generally speaking, I don't think .NET Monitor reports thread counts accurately. I think that's one of its problems. These values, which I'm collecting by analyzing, this is a custom gauge I created inside our own app. This is keeping track of the thread count. And 67 has been a pretty consistent value. Well, 67, 65, somewhere in that ballpark, has been a pretty consistent observed value whenever we're using the channel executor on .NET 6. This is one of the key values we want to pay attention to. So over here, we can see the total number of alive actors inside the process. We kill off actors that have not received a message every 2 minutes inside cluster sharding. That's why you're going to see a steady growth here while the cluster is scaling up. But now the cluster is fully mature, you're going to see actors, you're going to see some like peaks and valleys on here. And then if we look at the Phobos numbers, if I go and refresh this, looks like someone's been kicked out of the cluster. I don't see any huge errors. I'll need to go and double check what's going on there. But my guess, by the way, we're averaging this across 200 nodes. So my guess is that we're probably in a complete state. In fact, I can go ahead and check real quick what the cluster actually thinks. These competitors up the names. 200 nodes, we have one weekly up node here. So we have one weekly up node. Do we have any unreachable nodes? Now it says we have 200 up nodes. So I'll go ahead and do a cluster tail for the time being. This will allow me to go ahead and keep track of if there's any unreachable members or anything like that. We'll see that pop up here. Okay, so there was an unreachable member. It got removed. So my guess is that basically, so we're running 200 Akhenaten nodes, node per pod. A node in Akka.NET is basically just a process. So these are 200 processes that are all linked together. That's what we're running in this case. And the Akka.NET cluster is going to continuously exert some pressure on in order. It's basically a big peer-to-peer network is what we've built here. And we're just seeing how well it holds up versus the .NET Core 3.5 implementation of it. Okay, so I'm going to go ahead and copy over. You know what I'm amazed? I'm pretty sure I've got some syntax in here that uses. See if I can find it. I thought I used some of the record syntax on here, but looks like maybe I didn't. That'll make things a lot easier for me. I'm probably going to have to delete. I'm probably going to have to delete and recreate all of my data in Azure Storage, though, unfortunately, because I'm not sure changing from a record to a class if I'm going to be able to deserialize all of my data that's in there. That's okay. That's not the end of the world. Let me grab from my front end node. Yeah, I'm going to go ahead and grab my program.cs. Copy all this. Go over here. Actually, I'll hold off a second from that. The one thing I need to copy in here all right. One thing I really need to copy in here is I need to copy this. Here we go. Yeah, this is what I need. Just this little bit. Actually, I may as well just copy this. The Akka configurations are slightly different between these two node types. So let me go ahead and add all of that. Am I missing something in here? Aha, that's what we're doing. Okay. Now we're good. And that should do it. I should be able to delete all of this. And should be good to go. Let me go ahead and try compiling it. Looks good. Let me go ahead and try building. Looks like there's some churn happening in the cluster right now. And there is a bit of an error rate. So it looks like someone definitely failed over inside the cluster here. I think our issue is that we're probably running out of memory and pods are starting to get evicted. Yeah. Memory usage is climbing a little bit. CPU utilization, okay, there we go. CPU is around 14.65%. I'm going to take a little screenshot of that. Open it in paint.net. I'll go ahead and paste a copy of it, just so we can do a before and after comparison. That's looking pretty good. I'm going to go ahead and I'm actually going to go ahead and destroy. Well, I'll wait a second. First thing I'll go ahead and do is I need to get back to my root. Oh, you know what? There's one thing I need to do. Glad I remember this. Before we do this, I've actually got to change this back to, let's see, .NET Core 3.1. Otherwise, my Docker would be. Let's see, is this going to be .NET/Core/ASP.NET? Core SDK 3.1. think so. Let me do this for the front end too. That was good. That core app 3.1. Okay, let's go ahead and see if this works. Before I do that, and actually one more thing that I ought to do, update my release notes. Today is what, May 4th? This will affect the way my Docker is tagged. All right. Looks good. Let's go do build command Docker. This will run nuke behind the scenes to go ahead and compile my Docker images. I've got a little switch I can drop in that'll allow me to publish remotely to our Azure Container Registry. I will do that in a second. I just need to go ahead and make sure my Docker images are right. Plus, I might want to actually go ahead and run this in my local Kubernetes cluster just to make sure I'm not wasting people's time. Okay. Well, so far so good. Aha, you know what? Who has 2 years and is not running Docker on the machine? That would be me. All right, there we go. I don't have Docker for whatever reason doesn't start by default in my system when I reboot. So that's what happened there. Whoops. All right, well that should take just a minute. While that's happening, I'm going to go ahead and destroy. I'm going to go ahead and basically delete our production cluster. So this should scale down pretty quickly here. So it looks like we got just, I don't know, just under 15% CPU utilization. I might need to delete and recreate my APM system since its memory footprint is going to be elevated compared to what it was before, and that might pollute the test. So I might use Pulumi to do that in just a second. We'll see how it goes. I'll open a new PowerShell here. Akka.NET is licensed under Apache 2.0. It is a .NET Foundation member project. So if I go to GitHub here, and pull it up, and we take a look at the license. It is licensed under Apache 2.0, which is a permissive, commercially friendly open source license. So you can go ahead, and GitHub will go ahead and give you a little hint down here on basically what the license provides, I think. Although this is kind of an abbreviated version of it, the full license text is available. But long story short, you can totally use it for free. There's no problem with that. All the other libraries, with the exception of Phobos, which is the one producing some of these metrics, all of those are also Apache 2. Okay. So now let's see if Docker's up and running. Well, I'll go ahead and shut that down. We'll do Docker PS. And if this fails, then I know I've got a problem. You know what? I might very well have a problem here, actually. Yeah, it looks like Docker's definitely having some trouble starting. Wonder what that's about. Well, that'll certainly make it tough for me to run my demo here. I wonder if Docker upgraded or something like that. Yeah, let's go ahead and restart it. Not sure what that was about. Look at the settings here. Maybe it's an issue with WSL on my machine. Yes, I'm using Windows Subsystem. Sorry, Linux Subsystem 2 on Windows. Well, that would explain what's going on here. WSL's having trouble starting. Nope, it's up and running. Alright, so it looks like this is all fine. But WSL definitely took a while to spin up. Let me go ahead and do something real fast. Yeah, that's what I want to see status. That looks good to me. Take a look at the distributions. And then let's see, list. Looks good to me. Looks like Windows Subsystem for Linux is up and running without issues. Let's try Docker desktop data. There, looks like we might have a problem. You know what? I'm probably going to have to go back to settings. Probably going to need to go ahead and revert to my factory defaults on here, which is a bit of a bummer. If I go down here, this probably isn't going to work. I wonder if I can go ahead and run Docker within my other Ubuntu distribution that's native on this machine. Be a shame to lose all that work. Go ahead and commit all that. Move this over here. Alright, there we go. Go and publish that image. Yeah, this is all toast. Dang, I'm going to have to really reboot Docker. I wonder what happened. I use Docker all the time. I haven't used my personal development machine that I'm on right now in a little while. Okay, here we go. Looks like we're back to life. Well, that's nothing short of miraculous. I wonder what the issue was there. Let me take a look at something. I customized my Docker install to run on this drive. Basically, all the VM images are here rather than here because I kept running out of disk space up here. This is my system drive. This is my data drive. So, looks like it just took longer than usual to start up. Okay. Now let's go ahead and try doing what I wanted to do all along. Just building my Docker image. So we'll give that a shot. Let's see how things look on here. Actor count has plummeted down to 0. You can see this is from our cluster getting killed off. Yep, there's no active cluster anymore. Looks right to me. No .NET Monitor metrics, all that has stopped. Kubernetes is reporting that we're back down to 4.31% CPU utilization. So some of that memory is definitely going to be coming from a log aggregator that I have running elsewhere inside the cluster. Let's go ahead and go back the last 15 minutes. All right, that looks good. And let's see if Kubernetes will start. I'll delete this. That was a little rabbit and queue sample I was running. Okay, and let's see if my Docker image build worked. Did not. What was the problem there? Net Core App 3.1 publish not found. So when I publish these images, where do they get published to? Net Core App 3.1/publish. D repositories front end bin release. Net Core App 3.1 publish. Wonder if I typed something wrong. Net Core App 3.1 publish. Bin release. Net Core App 3.1 publish. That's all in there. That looks right. So the error message down here was load build context. Hold all of our images. Failed to compute cache key. Bin net release net core app publish was not found. All right, so I go to front end. Oh, right. See if that works. Yeah, the Docker context is correct. It looks to me like there was an issue where we actually didn't pull any of the right base images, given that, so it might have been a problem with Nuke, actually, Nuke build. Maybe this tool is trying to be too clever by half. I'm not really used to Nuke. I'm a fake guy primarily. It was my preferred .NET build system, but a member of our team took on this project to go ahead and modernize our build systems. We chose Nuke, so I'm along for the ride. And there might be something that it's doing where it's trying to, I don't know, do some of Docker's work for it. Could have just been a fluke. Could have been an issue with the way the Docker metadata was working. So I guess we'll see. Yeah, let's find out. But yeah, our build tool guarantees that we're basically working out of this directory. That looks right. All right, perfect. So that looks like it did what it was supposed to. Let's try running this again. think I have to run the build one more time, actually. I'm going to need to do it and publish the images live. I just wanted to go ahead and try deploying it. My local Kubernetes cluster is now running. Thank you. I just wanted to go ahead and make sure that everything works locally first before I try deploying into production. So in fact, go on here. Let me switch my Kubernetes context to Docker desktop so I can deploy into our local cluster. What is this thing trying to do? Nuke's doing something weird here, the way it's calling Docker. I don't quite get what the deal is with that. Docker image. Let's see. I'm gonna do something drastic. Let me figure this out. Let's give this a try. Yep. I want the build cache removed primarily. I think that's where we're running into trouble. And it looks like my webcam froze. Let me go ahead and deactivate it. And then activate it again. There we go. That should fix it. Drop the nuke on Docker. That's right. We nuked it from orbit. We're not playing around. I've got stuff I gotta do. Okay. Docker's definitely getting work out. So I was using 32 gigs worth of data before. Wonder where I'm at now. Down to 26.14. Yikes. Well, this should delete just about everything. That's pretty cool, actually. Oh, I guess I could have used this to clean up. Huh. Alright, well, while that's going, we'll go ahead and do build up command Docker. We'll go ahead and rebuild. So even though I'm in the middle of purging stuff, I'm going to go ahead and try to actually build my images anyway. Docker may not like that, but whatever. It can deal. Let's go ahead and flip back again. All right. Are we still having problems? Bin release netcore app not found. You know, I'm convinced there has to be an issue here with the way Nuke is doing this. Let's take a look. Fail to compute cache key. Let me see what this actually means. I always do my Googling off screen during the stream. Problem is that the Docker ignore file contains some pattern. All right. You know, I wonder if this is like a pathing issue. So know this file name's just about right. Let's give this a try. Yeah, you know, it might be possible that I am. Here's the thing, I don't think I have a Docker ignore file. That's the thing that's confusing me. Let's go ahead and do... Yeah, let's take a look. I don't have a Docker ignore. You know, oh, you know what? Let's take a look. What if it's Nuke doing something it shouldn't? Let's see. Docker file and Docker file. Let's get Docker projects. Let's see. Compile. It's fine. Let's take a look at Docker. Build Docker images, release not version, Docker files, Docker build settings, set tags. And there's no other settings I need to be aware of, right? Yeah, I wonder if Nuke does generate one. Let's take a look. Yeah, that's just for GitHub though. Directory.build. Don't see any issues with that. I bet Nuke is generating one. This is something that kind of annoys me, is when tools are basically not letting them manage themselves. If that is what's going on here. Let's take a look at published code. Okay, so we look for the Docker files. What's this? Serial log information. Okay. Log files first, .publish. Let's take a look at our build logs. Load Docker ignore. It says there's 2 bytes. Is Nuke running on .NET 6? You know, I bet it is actually. Let's take a look. Yep, it sure is. That was a good catch. I wonder if this all falls apart. once I do that. Yeah, it sure does. Discard that real quick. Well, it has no trouble building the images. It's this stupid file path thing. Failed to compute cache key. Bin release net core app 3.1/publish. And if I take a look in the folders, it is bin release net core app 3.1 publish. Let's see, when was this file touched? Yeah, that looks right. I think I need to go ahead and roll back that change too. That doesn't seem right to me. I know it worked locally when I ran it, but when Nuke ran it, it didn't. I wonder if Nuke's doing something really silly. Let's take a look in the file system here. Nuke. Keeps saying it's loading one. This is super annoying. There's nothing specific to here that has .NET 6 built into it, which is good. Nothing in there. Yeah, nothing in there. Let's take a look at that again. Yeah, just nightly aqueduct. Nothing in there either. What the hell is going on with this? I think you're right that Nuke is generating a ignore file. I just can't figure out how it's doing it or why. Let's go back to Docker. Yep, publish code. Build Docker images, get Docker projects. Says CPU quota. Process tool path. Disable pool. What do I need to do to turn this off? Let's see. Degree of parallelism. Well, I need to get around this problem so I can just deploy my app here, since I'm running out of time for this evening. You never expect stupid stuff like this to be what kind of gets in your way. Fail to compute cache key. Is it possible that path not found is not the actual error? Maybe .NET Publish is failing the Docker build step. Well, I checked that, and I know that the .NET Publish is working because I can actually see the output in the directory here. So before I did all that rewriting on the stream, there's nothing that would have actually populated this directory at all. So I'm pretty sure that that's working. The other thing that's a bit of a mystery is that if I go into the folder here, in fact, you know what I'm going to try doing? Because I'm pretty sure everything's going to work fine. But because I need to get on with actually deploying this to Azure, I'm going to go ahead and run this command. No, I'm not building inside of Docker. I always build from the build machine and then copy it in because I like to keep my Docker files relatively simple. It's also easier to configure dependency management on the build machine rather than inside Docker if you're working with things like custom NuGet sources. Particularly if I don't use it, but if we have customers that use things like Azure DevOps artifact services, authenticating into that's kind of a pain in the butt. You have to go and actually install like a custom piece of software to do it. Again, that's going to fail. But what I wanted to go ahead and grab, if I can log into here, is I wanted to see the invocation logs for Docker. This is what I want to see. I want the tags. All right, cool. I'll go ahead and grab this. Let's see. Go ahead and grab that. That looks good. Yeah, looks like it worked for me. All right. Ah, crap. Now that's interesting. Ah, because I'm in the wrong file. Never mind. So there really is an issue here with the backend app. The front end app worked fine, but there really is a problem with the backend one. So there really is an issue here. We've been looking in the wrong spot. Oh, hell, I know what it is. Dear God. We were not referencing the same value that directory.build.props uses. Oh, man. You were right all along here. Alright, you know what? I'm just going to go ahead and close this tab. Yeah, close that one. Okay. Now we can give that another shot. Alright. Get rid of that change. Fix framework reference. Go ahead and enter that in. Alright. Still had a problem here. File scope namespaces. Wow. I'm a fool. All right. Let's go ahead and try compiling that. Oops. I just need to import the right namespace here. If it'll let me, which it may not. Get rid of that. Let me just go ahead and copy this. Get rid of that. That really is missing still. Get required section. Did I accidentally alter that method call somehow? And what is this part of? Configuration extensions. All right, and is this library referencing something that my backend one isn't? Maybe that's it. Yeah, that would do it. Okay, I think I got that figured out now. All right, that looks good. All right, now let's go ahead and build everything locally, and then I'm going to run a local version of Docker here. Bump this to 6.0. That way, before I deploy everything to Kubernetes service, I can validate that it works. All right. See how that goes. Looking better so far. There we go. Okay. See if all my little Docker images are built. They are. That's great. I'm going to go ahead and deploy a local Kubernetes namespace. This is actually going to run on my own machine. And we just need to make sure the application works. That's what I'm going for here. Except my webcam froze again. Go ahead and fix that. All right. Okay. Now let's go ahead and see how things are going. My guess is we're pulling down a whole bunch of images right now. Man, I can't believe the issue was something that simple this whole time. Container creating. We must be pulling some images right now or something. See, we had a restart on one of the backend pods. Yes. One of the more services failed to stop. Object reference is not set to an instance of an object. Oh, this is an Allocations.net bug. That's what's going on with that. That's a bug that shows up with the channel executor. Yes, kubectl, well, kube control. I always call it kubectl and get made fun of for it. But yes. Yeah, it looks like my backend pod is having some trouble. Let me go ahead and try running front end node here. Just do it manually for the time being. Looks good. And then if I go and fire up the backend node, so I'll do this without Kubernetes. And looks like it's working. Great. Yeah, this is some ASP.NET error. This was two petaversional command instances binding. And then if I go back to my front end node, okay, cool. It formed a cluster, means everything works. We're good to go. No need to go ahead and keep my local cluster alive here, so I'll go ahead and delete it. All right, we'll go ahead and delete that. And then we're going to move Kubernetes back to our AKS cluster now. Last thing I'm going to do is I need to update my production service values. This needs to go to 0.6. Actually, it's not quite the last thing I need to do. I also need to update. I actually need to push these Docker images live up to AKS, or sorry, ACR. Let me go and copy this. This will go ahead and publish my images to my ACR repo. So let me go ahead and run that. This should take just a minute. Take a little look at how our cluster is doing. I'm going to do one thing to reduce memory usage in our production cluster real fast. There we go. This is seek, our log aggregators. And I'll go to events. So you can see these are all some of the logs we're aggregating from each of our individual nodes. Storage. Let's see, it gives it settings. And then I'll go ahead and say delete matching events. This should go ahead and basically purge all the events from seek. I should see our memory footprint go down quite a bit once that's finished. Okay, let's see if our Docker images are live. They are. That's great. So I think we're ready to go ahead and do our deployment now. Let's see how it goes. Here we go. Don't know why any of that happened. Here we go. Starting to see some network pressure. Let's reload Alcadoc cluster. Getting some data back from Phobos now. Seeing a lot of probing timeouts, just odd. And still in the process of creating these containers. Which seems weird to me. Guess those images are still being pulled. Alright, well, one half of the pods are running. Here we go. Alright. So I wonder if my readiness check is bad. Now this looks like this is Akada HTTP that's bad, actually. Hey MJ, how are you doing? You know what's weird is I've run this code on Core 3.1 and I've never had this issue with it. Let's take a look at something real quick. Readiness probe failed. Ugh. Dude, I know what's going on. Crap. I know what the issue is. Damn it. That's the problem. Then if I go to front end, it's because I'm not returning a value. That's the issue here. So I need to go ahead and bump my versions. So do 6.1. All right, that's fixed. Go ahead and rerun that. And then I need to go back to here. So basically the cluster couldn't form because I need a minimum of, I think, 3 or 4 nodes all responding back via Kubernetes Service discovery, and I could only get 2 because I accidentally did the wrong thing inside my readiness check. All right. That should do it all. All right. Go ahead and put that in. Push that up. This should be done in a moment. All right, looks like we pushed. It's great. Now we're back down kind of our normal ballpark again. Everything's live. Great. Deploy all. You need to set up YubiKey for GPG signing. Yeah, my GPG setup is pretty primitive. I probably do need to polish that up some. All right. What's good about YubiKey? Not that familiar with it. Okay, now we've got multiple pods all starting up at the same time. Let's take a look at Akka cluster. Looks to me like there's something going wrong with Akka management here. It's weird because I've had no problem using it before. I think I know what the issue is. Let's see. Yeah, I might have to do one more build. Synchronous operations are disallowed. And this is coming from Akka management, cluster bootstrap, internal. Okay. Wonder why this wasn't an issue before. Guess I can't do that. Let's see. Whoops. I accidentally nuked my whole desktop there. Go ahead and bring that back up. Let's see. Yeah, I'm not going to be able to get my cluster to form until I figure that one out. So I may as well pull the plug on the system for the time being. Call read async. So this is something that we'll probably need to go ahead and patch inside Akka management. So let me go ahead and file a bug for that real quick. I'll have to clean this up later. Alright. There we go. Got that logged. Let's see if there's a way to figure Kestrel here. If I can't do this tonight, then I'll probably need to call it here. Endpoints. Let's see. Actually, you know what? Maybe I need to RTFM my own code here. Cluster Bootstrap. Let's see if there's any issues on Netcore 3.1 for this stuff. Routing middleware. Let's see. app.use Akka routing middleware. This all looks fine. TSL. Server binding. Let's take a quick look at this. Looks like my music stopped. Well, let me go ahead and pick that back up in a moment too. Well, you know what? I'm probably going to need to go ahead and call it a night here. It's 11 p.m. and I get up pretty early. We will go ahead and get to the bottom of these performance issues with .NET Core App 3.1. So I will go ahead and start by first taking our. I'm going to go ahead and wind down my Kubernetes cluster for the night. So go ahead and move back here. And we'll go to prod, APM Kubernetes, Pulumi, destroy. Yes. Let's go ahead and delete our resources here. I'll destroy that, then I'll destroy the Kubernetes cluster itself, and we'll go ahead and give this a try again tomorrow. But we need to get to the bottom of what that HTTP issue is before we can try running this. I've run Akka management without any issues at all before on .NET Core 3.1, so I'm sure that issue is related to my ad hoc ASP.NET setup. So I'll take a look at that. I wonder if the issue is like Kestrel hosting or if that has something to do with it. All right, everyone. Well, thank you very much for your time tonight. I really appreciate it. And we'll go ahead and catch you next time. I have not been very consistent about doing my stream. I will be exporting these clips to my YouTube channel. And you can also, of course, always follow me on Twitter. I'm pretty active there, and I post quite a bit on our company's channel as well. So thank you very much. Really appreciate all of your participation tonight. Dopair, thanks for subscribing. Looking forward to seeing you again.